Hello folks, welcome to the crash course of the SourcePawn programming language. So let's just go ahead and get started. If you haven't programmed in C, C++, or Java or anything like that before, then this video is probably not for you. I'm going to be moving pretty fast. So let's go ahead and start. Pawn was created by a company called CompuPhase and was adapted for use in the AMX Mod X gold source mod, so that way you could create your own plugins and stuff like that. Back when this was created, Pawn was adapted, and then when the source engine came out, SourceMod followed, and then a fork of Pawn happened. So what we're doing is SourcePawn. It was forked, and a lot of work has been put into it, a lot of performance improvements, and some syntactic sugar added. So it's pretty good. So let's just dive right in. So pragma semicolon 1 basically forces semicolons, because this programming language is totally fine with you not putting semicolons at the end of your statements. So doing this assures your sanity. Pragma new decals required also forces you to use the new syntax. We're not going to be teaching the old syntax. The old syntax would be things like this, and it turns red because it's bad. Basically use these two always and forever. So we're not going to be doing anything with the old API. The new API is much better. It was released along with SourceMod version 1.7. We have a few data types. We have int, we have float, we have bool, and char. These are the 4 primitive types. There's a few other ones that come stock with SourceMod, like handle and a bunch of others. But these are kind of the main primitive data types. Everything besides char is a cell t. Internally, a cell t is just a 32-bit integer. So floats are 32 bits, they represent a cell. Bools 32 bits represent a cell. Integers 32 bits represent a cell, right? Okay. Only difference is how they're interpreted in the VM. So we have those. You can declare variables normally like this. You can declare arrays like this. You can declare arrays where you don't know the actual value until runtime. Jesus, I can't type. New int. If you don't know the actual size, then you can do something like this, and that's perfectly fine. This will compile. So we got this going on. This can happen obviously with any of the other data types. So we have things in the global scope. Global scoping is fine. This is perfectly good. You can mark it static if you want. That's also perfectly fine. Except static limits the usage of A to this specific file we're working in. No one ever does this. So basically don't use static globally. You can also have static in a local scope, right? This is perfectly fine. This has A pretend. The A is really a global variable here, but its scope is limited to wherever it's declared, right? So you can't access A globally, even though it's really a global variable. Helpful for some things. So moving forward, public is obviously a keyword here. If you're familiar with object-oriented programming languages, in which SourcePawn is not, public basically allows the SourcePawn virtual machine to call into SourcePawn code. This is required for global forwards, which onPlugInStart is a global forward. Basically, anytime onPlugInStart is defined in your code, it will be called. SourcePawn automatically checks for it and then calls it yourself. You can have private forwards, where if you have register console command, right, and you have some command in console, and then you have command test, for example, you can declare public action command test. It's going to take 2 variables, or 2 parameters. It's going to take client, I can't spell, and it's going to take args. Perfect. So this is a private forward. If this is a forward, this is a private forward, and it doesn't need public, but you should probably leave it there for sanity. Also, parameters, these are what's specified in the documentation, but if you don't use them, you can go ahead and remove them. I don't know why you would. It doesn't warn if you don't use them. So that's the difference between private and public forwards. That's when calls in C++ are forwarded into your code in SourcePawn. You also have natives, which if we go back to this example, register console command is a native because it calls into native C++ code, where they register your callback to this command, and then will call it themselves. So basically everything's either a native or a forward. Public plugin my info is a stock way for SourcePawn VM to identify what the information about a plugin is. If we were to look at the declaration of what plugin is, it would say that it's a struct, but in reality, it's really like not a struct at all. Yeah. So moving on, you can declare your own functions, right? So if we do something like this, you can go ahead and return a plus b, right? It makes total sense. And if you don't use it, it'll error, of course. But if you mark it stock, what that goes ahead and does is it allows you to not use things. This is really helpful in include files when you have a whole bunch of functions and you're not sure whether or not you'll use all of them. They're only meant to be used in include files. If you use stock in an example like this, where you don't actually use the function, you should probably just remove it, because the compiler is not even going to compile it anyway, and it's just a waste of lines. We have standard loops. While true, obviously this behaves as expected. You can do for int I equal to 0 if I is less than some number n, I plus plus, right? That makes total sense. We also have do whiles. It's the same form as C++. Similar stuff. We also have switch statements, right? And you can assign variables inside of evaluation scopes, and the variable, like in this case, it'll evaluate to 5 while also setting a equal to 5. So you can have a case for 5. That case can have code blocks to it like this. There is no fall through, so there's no need to break. There's no fall through at all. Keeping with this going, obviously we have post increment and pre increment. They behave as expected. And yeah, so moving on to arrays. So if we have an array A5, right, and we pass that into some function, that array will always be passed by reference. And while normal primitive types are always passed by value. You can force references, so if you have some function, right, you can accept a reference to a variable and then obviously assign that to something. So you can do test2 and then give it b, and it will go ahead and modify the value of that. That'll work perfectly fine. Yeah, so arrays are always passed by reference, primitives are always passed by value. There's also enums, right? So if you have an enum for time, this makes no sense, but whatever, and you have night or you have day, then you can create a time thing t equal to night, right? This is perfectly fine. Enums are really numbers, so you can assign them to a number and it'll start counting. So that means day is going to be the value of 33. But you can also just override that and do whatever you want. That's perfectly fine. This does not, since these are really integers in the background, if you wanted to convert this to an integer, you'd go ahead and you would cast using view as integer. Kind of looks like C++ static cast or whatnot. Or if you're lazy, if you prefix the enum name with a lowercase, then it'll go ahead and convert implicitly, right? Or if you decide not to have a name at all, since it doesn't have a type, these are just named integers, right? Fairly nice, easy to work with, makes things easier. We also have these things called enumstructs. Its history isn't really important, but these are basically stack allocated structs. There's no concept of pointers in this. There's no concept of pointers in SourcePawn at all. There's this thing called there's a data type called handle, but I'll explain more about that later. So if you have a struct for time, right, you can have a timestamp and timestamp. You can have your own, like, I don't know, getters or what have you, and you can go ahead and return timestamp, you know, whatever you want. That acts like a struct, but in reality it's just a nasty array. And when you're calling stuff, it's just, you know, it's whatever. Yeah, so moving on, you can't return strings in the normal way that you would expect. To do anything Like let's say we did this. If you wanted to set that, if you wanted a function to populate that that string, that character array, you would do something like this, size of a, and then whatnot, and it would populate this. There are format specifiers, so S for string, D for integer, F for float, and obviously 0.2F for precision and stuff like that, whatever. It's all pretty intuitive. Yeah, so we got that going on. You can return strings if you really want to, but it's pretty garbage. It'd have to be in the form of this, so let's just say get string, I don't know, doesn't matter. So we have our own function called getString. Let's say we have the string equal to test, and then we return AWD. You can't just do this. This just does not work. It cannot happen. But what you can do is that you can use it in function parameters. So if we use that format example and we have some buffer that we're populating, and we have our format specifier here, you can go ahead and put getString like this, and that'll do just fine. And that's kind of like a hacky way to return strings, but you probably shouldn't do that anyway. It's kind of a bad decision, but whatever. So like we were talking about before, there's no concept of pointers. So there is the handle data type. Basically what a handle is, all it is an index to a table that's held by SourceMod itself. And when you use the handle, it does a lookup on the ID that you are giving it, because all the handle is an identifier. And then there's actually a raw pointer in the background that it does whatever operation on. So if you wanted to create an array list in the old syntax, you would use create array, right? This would create an array list, and you could do things like push array string, and you'd give it the handle and then the string, right? There's a new way to do this. Like I said, this is old syntax. The new way is much more sane. You would have an array list, new array list, right? That makes so much more sense. Yeah, so you have an array list, and you could do awd.push int, push value. Is it value? Oh no, it's just push. And then you could give it something like a number. And boom, you're pushing a number onto this. The default block size for this is just one cell. If you're storing a string, right, if you're doing push string, and it's mental string, since there's no generics, you have to specify the block size for each one. So if we're pushing a string, and we do AWD, we can't just put like an arbitrary size here, because this is counting the number of bytes, right? When you're doing strings, you have to convert it to cells. Or sorry, this is the number of cells, but with strings, obviously you have a byte count, because strings are different than cells. So a character is 1 byte when everything else is just an integer, so you have to do byte count to cells. And then there you go, and now you have 32 bytes just converted to cells. Or else if you did this, you would not get 32 characters exactly, it would be something else. Yeah, so moving on. If you're wondering how this works, this is really just a handle in the background. So all that it is, there's this thing called method maps, where you go ahead and you can create your own data type and base it around a handle, and then here you could attribute methods to the handle, right? So so if we did, let's just recreate push string, right? So we're going to take some character or some array, right? What we could do is we could push array string, and we give it the handle, which is just this array list, right? So it would just be this, and then we'd push that string, right? That's basically in the background all this is doing, and methodmap allows you to attribute fake function, or sorry, it allows you to fake object-oriented programming by just mapping these to the old counterparts. And that's basically all it is. Nothing's really object-oriented in this, even though it kind of feels like it sometimes. You can also have natives. So if you have native int function, let's just say it takes a variable, right? Native, when you define a function prototype as native, basically what you're doing, you're saying that, hey, this function actually exists in native C++ code, and there's no body here. During run, and this basically satisfies the compiler. So if you tried to use function, right? Let's just do 32. If you tried to compile this, it would work fine. Whoops, I can't spell. If you tried to compile this, it would work fine, but at runtime, if you didn't have an extension that actually bound function to anything, it would fail. So basically, that's how native calls work. You can also create your own natives for other plugins. So you can have one plugin call a native that actually is just a callback into your code. That's through create native, right? So we'll just say the function's called funct, and we'd have some callback, right? And that callback, whatever the prototype is, its native call, whatever that is, that's what you'd get back. Yeah, so I think I already talked about the fact that everything in reality is just 32-bit cell type, except strings. Pawn is it's very weakly typed. Anything can be cast to anything else. It's not garbage collected, so if you do create an array list, let's go back to this example, new array list, right? So if you do create it in array list, and you just left this here, this would live in memory forever, and SourceMod would hold on to this pointer forever. So you have to do delete AWD, and it would allow you to close that handle and free it. There's also close handle, but you should not use that because it's bad. Cool, so we have delete AWD. It's not, like I said before, it's not object-oriented, everything's faked. SourcePawn is also single-threaded. If an extension or something were to call into SourcePawn outside of the actual main thread, then the extension would probably crash, or SourcePawn would crash. Something would explode and be bad. Obviously, this is a compiled language. It's not interpreted. It's faster than Lua, faster than things like Python or anything like that. It's genuinely pretty decent in terms of speed, which is why it was chosen over those counterparts. Yeah, so that's basically it. I don't think I missed anything of too much importance. There are some other weird tidbits, but I can't think about it at the top of my head. I'm not scripted. I'm not really, checking anything. So, yeah, if you guys have any questions, hit me up in the comment sections below. But like I said before, if you didn't understand certain things, that's totally fine. I was moving quickly on purpose. But yeah, if you have any questions, hit me up in the comment section below. Else, have a very good day. I'll see you around.